One of the ways that we have applied this methodology at the SCI is with a product that we call malfaces. And the problem that we're trying to solve here is, let's say that you're a malware reverse engineer, and what you're given is a pile of suspect files, and your task is to figure out which of these files are related to each other. In sort of the traditional ways of doing this, what you often are reduced to is opening up a file in a disassembler, looking at all of that disassembled language, and then opening up another file and comparing them side by side. And this manual pairwise analysis is very expensive to do. So what if instead we could use those three different roles and give ourselves something better to work with? So this is what we did. Instead of relying on the subject matter expert to do their analysis, we had an engineer take those suspect files and break them down into a way that a machine learning algorithm could understand. And then we had someone like myself come along and perform different similarity comparisons and make a statistical visualization, so that now when you just sort of stare at this thing on the screen, you can see that those suspect files that appear in your operating system, that first one and that third one, are actually relatively similar to each other because we've expressed them in a way that you can immediately see them as faces. And by using these sort of key components, we have the subject matter expert that says, oh yeah, those two files are actually quite similar to each other, so we can check that. We have the engineer that can make sure that we can break this down at scale, and then we have someone like myself who's a machine learning research scientist to sort of tie it all together.